Welcome to Summarize Science. Have you ever wondered how the largest galaxies in our universe came to be? Today we're looking at a groundbreaking observation from the James Webb Space Telescope that gives us a front-row seat to the birth of a cosmic behemoth. The subject is a distant object known as TGSS J1530+1049, located so far away that we're seeing it as it was when the universe was only 1.5 billion years old. For years, this was a faint mystery, but JWST's incredible power revealed it wasn't one galaxy at all. As you can see in these incredible images, it's actually one of the densest groupings of galaxies ever found from this era. The researchers identified at least 6 distinct galaxies, labeled here from C1 to C6, all packed into a remarkably small patch of sky. They also found 4 more regions, L1 to L4, that are glowing brightly with energized gas, but have very few stars. Now, what's powering all this activity? The yellow contours show powerful radio emission, which astronomers trace back to component C2. This means C2 is the host of an active supermassive black hole, or AGN, which is blasting out jets of plasma at near the speed of light. And this is where it gets really interesting. Look at the image on the right, which shows the distribution of glowing hydrogen gas. The gas forms an almost perfect line, stretched out across thousands of light years, perfectly aligned with the radio jets from the black hole. However, the galaxies themselves, seen in the image on the left, are scattered all over the place. This tells a story of 2 things happening at once. A central black hole is lighting up its surroundings, while the entire system is in the middle of a chaotic, multi-galaxy merger. Scientists can even see this merger in action by mapping the movement of the gas. This velocity map shows that one side of the system is moving away from us, while the other is moving towards us, a classic sign of rotation within a messy, interacting structure. The map on the right also pinpoints where the radio jets are slamming into gas clouds, creating extreme turbulence. And these aren't small galaxies either. This chart plots stellar mass against the star formation rate for each galaxy. Most of them lie on or above the main sequence, 4 typical galaxies at this time, meaning they are furiously building new stars. For instance, Galaxy C3 is churning out new stars at a rate of 163 solar masses per year. So, what does it all mean, and what's the future for this system? Let's recap. We have at least 6 massive, star-forming galaxies, one with a powerful black hole at its core, all caught in the act of merging in the early universe. This is an incredibly rare find. Based on their close proximity and relative speeds, astronomers predict that all of these galaxies will eventually merge into one single, gigantic galaxy. This object would be what's known as a brightest cluster galaxy, the massive galactic titans that sit at the heart of the largest galaxy clusters we see in the universe today. In essence, the JWST has allowed us to witness the ancestor of a modern galactic giant during its most chaotic and rapid phase of construction. This gives us an invaluable piece of the puzzle of how the most massive structures in the cosmos came to be.